Look at chapter 10.5. We're going to look at an ordinary general annuity. And an ordinary general annuity is different than the ordinary simple annuities that we've looked at, in that everything up till now we've had, so we had a simple annuity, this meant that our payments are on the same schedule as the compounding. Okay. So in other words, we said our payments per year is the same thing as compoundings per year. Well, instead of doing this, that's a special case of saying an ordinary general annuity where we have our payments have a different frequency from the compounding. And we saw when we had equivalent rates, we had our rate is equal to 1 plus I1 to the M1 over M2 minus 1. What we're going to look at for ordinary general annuities is we can calculate I this way, or we're going to talk about compoundings per year and payments per year. Okay. So this is where we have differences between the frequency that we're calculating interest and the frequency where we're making payments. So here's the secret. There's a lot of mortgages in Canada. Almost everybody that buys a property has a mortgage. And if you go to a mortgage, you'd say, well, we can pay a mortgage either monthly, semi-monthly, so on the 1st and 15th of every month, or we can do it bi-weekly, so every 2 weeks. Because if you get paid every 2 weeks, you may as well pay your mortgage every 2 weeks. Now the thing is this, if I was having a mortgage, which of these three would I like? Well, I probably wouldn't like bi-weekly because this would mean more compounding, which would mean more interest cost. And so that doesn't appeal to me. So we have a rule in Canada that says mortgages can only compound semi-annually. Okay. So what this means is if you have a mortgage problem, we're going to say that we're compounding semi-annually, but we can still pay monthly, semi-monthly, or bi-weekly. So we need to be able to convert interest rate to the payment frequency. All right, so we'll take a look at a problem. We're going to say, we'll take a problem from the book. We'll do question 12. Annuity consists of semi-annual payments of $950 for a term of 8.5 years. Using a nominal rate of 9% compounded quarterly, calculate the annuity's present value and future value. So we're going to take a look at a simple annuity where we have, an ordinary annuity, where we have $950 payments. Each payment is $950 over and over and over. And we're going to have this is year 0 and this is year 8.5. And we're going to calculate this compounded quarterly. So this is a rate of 9% quarterly. If we do that 9% quarterly, but we have semi-annual payments. So these payments are semi-annual. So we have semi-annual payments, but a quarterly interest rate. So the way we'd approach that before is we'd say, well, I2 is equal to 1 plus I1. And the I1 was based on our interest rate. So it's not just going to be I1. This is going to be 9 over 4 to the 4 times a year compounding for quarterly divided by the 2 times a year compounding for semi-annually minus 1. Or we went into our calculator and we said our in I-convert, we said our nominal rate was 9, our compoundings per year was 4, and we calculate our effective rate, and then we say our compoundings per year was 2, and we calculate a nominal rate, and then we're going to divide that by 2 to get I2. Well, we can actually do this fairly simply with our calculator by using the C per Y and P per Y buttons. So looking at the stuff that's in our problem, well, things are simple. We have a payment of $950. We have an I per Y of 9. We have compoundings per year, just like we had here, of 4. So this compoundings per year relates to the quarterly part. We have payments per year, which was 2. And this payments per year relates to the semi-annual payments. And then we had 2 problems. So the first one is calculating the present value. So here we're going to say that if the future value is 0, we're going to compute the present value. Or if the present value is 0, we're going to compute the future value. Putting this in our calculator, we say, well, we have $950 payments. We have 9 as our interest rate. And then we're going to go second function, I per Y, and it says how many payments per year. And we say we have semi-annual payments. Semi-annual is twice per year, so we're going to do 2, enter. If we go down, the default is going to be the same for the compoundings per year. But our compoundings per year, we're going to say this is 4, enter. So we have the same payments per year, compoundings per year between the two, or compoundings per year 2, payments per year, so payments per year of 2, compoundings per year of 4, which is right for our problem. Sorry, we're missing an n. Our n is going to be, well, number of years, 8.5 years, times this payments per year, because n relates to payments. So this would be 2, 17. So 17 as an n. I'm now going to check those. N is 17, I is 9, payments are 950. I'm going to set 0 to move my future value, compute the present value to be negative 11,079.10. And if I put 0 in my present value, I'm going to compute the future value to be negative 23,607.90. So what we're looking at is to do a full general annuity problem. We not only know the payment like we had before and the I per Y, and we used to calculate I as an equivalent, but doing this is a lot of work. So the things that were new were compoundings per year was new, payments per year was new, and that's basically just doing the second function button. N is the same as we had before. Future value and the present value, the idea is the same we had before. We're now just going into the second part of our calculator.